Now, genetic algorithm, it is introduced by John Holland in 1960. This algorithm is all based on Darwin's theorem or Darwin's theory. Darwin says that it is talking about evolution of human race. Let's say if two parents has come up, they will generate a children, and that children will get best of two parents. In that way, the human being evolves. Okay, that is the theory given by Darwin. And based on that, John Holland has introduced an algorithm which is called genetic algorithm. And further, John Holland's student, that is David E. Goldberg, further extended genetic algorithm in 1989 and comes up with the genetic algorithm in today's AI syllabus that we use. This particular algorithm is the abstraction of real biological evolution. Real biological evolution means, just I told you, two parents get together to birth a children, and this particular children or child has the best quality from its parents. So that quality is called its genes. So some genes of mother and some genes of father will be passed over to the children. And they are thinking in that way, like if we have two good parents, they are generating a good child, and again some good childs are generating some more refined good children. In that way they are evolved. These type of algorithm is very much useful to solve some complex problem like NP-hard problems. And mainly this genetic algorithm is focused on optimization problem. Optimization means generally we have number of solutions, or we have some state space where we have some solutions, and from those solutions we have to find out the best solution. To finding out the best solution, that process is called optimization. And to get the optimized value, we use these type of algorithm which is called genetic algorithm. Okay, so we'll see one example, max one problem, how we have deal with genetic algorithm, that we'll see in the later on PPTs. Now let's talk about genetic algorithm furthermore. Let's see, this is the India population. You assume that. Now there are some good person and there are some bad person. Let's say the good person or the population of the good person, I have put it as blue, and the population of bad people or the bad person, I have put it as red. Now let's say they have divided the good people and the bad people based on their some value. That value is called fitness value. Okay, fitness value means I need good people is my fitness. Okay, so how good my people is based on their criminal record. Let's assume that there are some people who has the criminal record, so the fitness function value will be less. And there are the people who has no criminal record, so fitness function value is more. Now what will happen in this particular example is, let's assume that this is the India population, and let's say the government policy came like only good people will able to reproduce their children, and the bad people will stop the generation of the children. So what happened at some after some time, or let's say 10 year or 20 year or 30 year, you find out that the blue dots will be more here in that particular map. So what will happen is the number of good people will increase. That is the theory behind genetic algorithm. It means we want to reduce those population which has least fitness value or the fitness function cost. So here in the genetic algorithm, we use some terms. What are the terms that we'll use? That is called population. A1, A2, A3, A4 are called population. Now, A1 or A2 are called chromosome. This is called chromosome. And in one chromosome is built up with different gene. So one particular unit of the chromosome is called gene. So this is gene, this is chromosome, and there are many chromosomes. It is called population. Okay, it is called population. It is just like, let's say we have 4%, 1, 2, 3, 4%. So in these 4%, one person will be indicated by this, another person will be indicated by this. So this is called chromosome. Now in each chromosome we have some gene, and this gene is there in the form of, let's say, 0 and 1 or some values. Now from here we calculate the fitness function, and from the fitness function we'll get some values, and based on the values we select. So here how we select the population? We'll select the population with their fitness function, and after selecting, what we do reproduction. Means we'll do some crossover. Means we have some male and female, we'll do the crossover and we'll generate the population again. And this population, we do some mutation, we do some refinement, and again we'll find out the fitness function of that, and whoever is not the fittest will remove it. So you can see the genetic algorithm is we can say it is the algorithm for the survival for the fittest. Okay, so whatever chromosome which has good fitness value will be participated in the reproduction further, and the chromosome which has least fitness value will not going to participate in reproduction. So in that way we are going to refine our solution. After refining the solution, after some time we'll get some optimal solution. That is the idea behind genetic algorithm. Now let's go further to the genetic algorithm and try to understand its algorithm. Now what will happen in genetic algorithm? We have two parameter here of a function, that is population and the fitness function. So what we do, we put the population. Let's say the population is of our country is 1.25 1.25 thousand or 100 crores. So that is our population, right? So that population will put, and will put the fitness function. Let's say the fitness function is based on, let's say the from 0 to 100. Let's say we are taking some fitness function of based on their criminal record. So if there is a criminal record, there is not the criminal record. Based on that, we'll find out some values. So that is my fitness function. And what we are returning some individual. So from the population we are returning some individual, and that individual are nothing but my best solution or the optimal solution. So input are population and the fitness function, the function that measured the fitness of an individual. Now we have the empty set, that is your new population is taking as a set, which is an empty set. Now we are starting our loop from 0 to the size of the population. So it will go to 1.25 100 crores. And there is a random selection we'll do of the population based on the fitness value X. Another random selection we'll do based on the fitness function Y. And after that we'll take X and Y and we'll do reproduction, okay, to get the children. If there is a small probability, then the child will be mutated. the child will be mutated with some positive values, and then if the child is a new population, the new population will be given to again to the population, and this value will go on and on and on till all the iteration will be over, and all the we are getting the good optimal solution. So it will go until some individual is fit enough or enough time has elapsed. So both are the condition. Either let's say we are taking this genetic algorithm for 10 years or 20 years, and after that we'll stop the process, or we'll go to a fitness value. Let's say we are getting, let's say 100% fitness value of all the population, then we'll stop this particular process. So both the thing can be the out condition for this particular loop. And what we are returning the best individual in population according to fitness function. So fitness function, who is having the highest fitness function, will take that individual as an output. Now this reproduction function, how this reproduction function works. So in the reproduction function, what we do, we know that what we do, we have two parents. These two parents, X and Y, will take as an input, and whatever length of the X is, will put into the N. We'll have some random value from 0 to N, and we'll pick up. We'll put the substring of X, will start from 1 up to C, and another substring will take of Y, will start from C plus 1 to N, and will just append both the string. So that is giving you the crossover values, and that crossover values actually we are returning. So what will happen is, children is nothing but the crossover. Crossover means children has some property of the mother and some property of the father, right? So that will become a children. In the same way, if we want to produce the child, so some property of one parent and some property of another parent will be take up and append. In the same way it has been taken here. So randomly some length has been taken from one string, and we have taken that particular string up to that random value, and from that random value plus 1 up to the last value we have taken from Y, and we merged up and we'll append it. Let's see the same process with one example. This is the initial population we have, and this is called chromosome, right? This is one chromosome, this is another chromosome, this is another chromosome, this is another. So we have 4 chromosomes available. This is your initial population, means this is my initial values, where we have 4 population. Now every population will have some fitness function, and it is generating some values. So this fitness function is 24, fitness value is 24, 23, 20 and 11. When we add up all these fitness values, so how much we'll get? It is 4, it is 8, and it is 1, 6, 7. So 78 is the total fitness we got. We didn't get 100% fitness, we get 78 fitness value. Now we'll get the percentage. How we'll get the percentage? 24 divided by 78, it is 31%. 23 divided by 78, how we'll get 78? By adding all these fitness value. So we are getting some percentage. These percentage will take for the further selection from the initial population. Okay? Now, which has having the highest fitness function, that particular chromosome has the highest chance to be selected. It is obvious, right? So who doesn't have the criminal record? Definitely that person has the highest possibility to get selected for the reproduction. In the same way, here depend upon that percentage, that selection will be done. So you see that because this chromosome has the least fitness value, so it has not been selected for the further work. Instead, what will happen is, first chromosome will be selected, second chromosome will be selected, again second will be selected, the third will be selected. Okay. Now after the selection, what we do? We do crossover. What do you mean by crossover? From two parent will generate the children, right? So let's say this is one parent, this is one parent. So we'll generate the children by crossover, and for doing that, either we'll have a single point crossover or multi-point crossover. Here we have single point crossover. If you see this example, this is 3 2 7 5 2 4 1 1. Here it is 2 4 7 4 8 5 5 2, right? Now single point means in a single point we just divide these two chromosomes. So what we get? We get 3 2 7 in one part, 2 5 4 1 1 in another part. So what we do is we just swap these values. So what we'll get? We'll get 3 2 7 4 8 5 5 2. See, 3 4 7 4 8 5 5 2. And for crossover, this one 2 4 7, what will get? 5 2 4 1 1. 2 4 7 5 2 4 1 1. So this is my crossover value. Means you see these are two parents, they are generating two children by some crossover points. So this is another chromosome that we are generating. So this is your new population that we are generating from the old population. Getting it? Here, let's say the single point is the point is 5. Here the point is, let's say 3 we are taking. Here it is 5. So in that way that you do the crossover. It can be anything based on your genetic algorithm. Now after that crossover, we get the new population. In that particular new population, we do another method or another step which is called mutation. Now in this mutation, what we do is we increase the chance to get the higher physical fitness function. What we do? We change some gene so that we can increase the fitness function. That's all. So randomly we choose some genes. The genes will be, let's say here the genes is 5. That 5 will be replaced with 1. Here there is no changes, no mutation. Here this 7 will be replaced with 2. Here this 1 will be replaced with 7. So in that way we do some mutation. After that we get a new population. In this new population, again we do the same thing. What we do? We get the fitness function, and from population we find out which is the fittest or which is giving you higher fitness value. That population only will select for the further reproduction, and the chromosome which is giving you least fitness function value, that will leave. So it is just, as I told you, survival for the fittest. So whatever is the fittest chromosome will go further for the reproduction, and the chromosome which is having the least fitness function will not go for the further reproduction. So this is all about your genetic algorithm. Okay, let's see the same process here in terms of a diagram. So the same algorithm which we have seen, let's see with the help of a diagram. Here we have some initial population. In the initial population, we calculate the fitness, and based on that fitness, we select some chromosome, some population, right? So after selecting some population, we do the crossover of those population, and after doing the crossover, we do some mutation to again increase the fitness function value. After that, we'll see the stopping criteria. What is the stopping criteria in the algorithm? We have two stopping criteria in the algorithm. Whether we have reached the fittest individual or we have done enough number of iteration. So if any of the condition is satisfied, we just go to the optimal solution after that. If any of the condition doesn't satisfy, we again go to finding out the fitness value of the newly created population after the mutation. Okay. Now, what will happen after that? Again, we'll do the same process, the selection, crossover, mutation. Again, we'll go to the criteria, whether we'll stop or not. No. Then we'll go again for the fitness calculation. Again, we'll select, again crossover and the mutation. So this process is go on in the genetic algorithm. Let's see the same process with the help of an example.